Okay, so a little bit of recap. Remember, we're talking about sequences. What are they? They're just a set of numbers in an ordered pattern. We're mostly dealing with infinite sequences, but they can be finite, meaning they have an end. Infinite go on forever. It is important that you guys understand the subscript notation. B sub 2 means the second term of the B sequence. Here where we have R, over here where we have R sub 5, I'm sorry, right there, R sub 5, it means the fifth term of the R sequence. That's really important that you know that. How do we know something is an arithmetic sequence? We'll know that if it has a common difference, a constant amount between each term. If it does, it's an arithmetic sequence. We then have a recursive formula for an arithmetic sequence. That's the one you dealt with last night. The drawback to the recursive formula is you must know the previous term to get the next term. That's what n minus 1 means, the previous term. If I want to find the 10th term, I have to know the 9th to use this formula. If I want to know the 100th term, I have to know the 99th term to use this formula. So it's a little restrictive in that if you don't know the previous term, the formula will not help you much. All right, from there we did some problems, writing the sequences, and that was the homework. And so now let's get into the more valuable formula, and that is the explicit formula. E-X-P-L-I-C-I-T, the explicit formula. You need to take notes. So get some paper out and get rolling here and take notes. So the explicit formula is used to find any term of a sequence. You can see it's a lot more valuable. We can find any term of the sequence. So let's see if we can try to understand what this formula means, because we got to understand what each part is. Can somebody tell me what we mean by A sub 1? What does that mean? A sub 1. Ashley? Exactly. This is the first term of the sequence. Okay, so the first term of the sequence is listed in the explicit formula. So we'll need to know that. Do the easy one next. Somebody tell me what this red D stands for. Brendan? It's okay. Colby? It is the common difference. The common difference. And remember, that's the amount from one term to the next term. Common change of the amount from one term to the next. Now, the only thing left is n. And n would go along with whatever term you're trying to find. Whatever term you're trying to find. If you're trying to find the 10th term, n is 10. If you're trying to find the 30th term, n is 30. If you're trying to find the 11th term, n is 11. So that's all n is. Okay, so let's see if we can use that and solve some problems. All right, so our first situation here, it says if A, that's our sequence, right, equals 2, 5, 8, ... And we see here that we have an infinite sequence. It wants us to find A sub 15. We want to find the 15th term. Now, you can go the slower route, or you can go the, you can go the counting route, and you can count to the 15th number. But remember, we teach you the concept with easier things. Really where we'd like to go, and it's a little bit hard to go there till you get your calculators, I'd love to ask you the 712th term. Now, it's no problem if you got a calculator. It's like that. Now, until we get a calculator, it's a little bit more work involved, so we don't usually ask you for something that large. But you definitely don't want to count up to the 700 and whatever term, right? You'll be there forever. So again, let's learn how to use the formula. That's the idea. Okay, so if they give you a sequence and they say find like the 15th term, the 80th term, the 13th term, the 75th term, we're going to use the explicit formula. All right, so I wrote the explicit formula. Notice right off the bat that I wrote a sub 15, right? Well, because the 15 is there, let's first off, before we go any further, somebody tell me what is the value of n? Go for it, Luke. What was your first instinct because you went to raise your hand? Okay, no, that's okay. There's actually a value here. Edward? It is 15. N is the value of the term that we're looking for. So, and if this helps you guys, notice in the actual formula, there's an n there, but now as we're applying the formula, there's a 15 there, right? N is 15. Okay, so it's important to know that. It's going to help us in the formula. So notice, not only did a 15 go here, but in a moment, we're going to stick a 15 there, right? All right, let's look more at the formula. I have an a sub 1 in the formula. Where is a sub 1 going to come from? Julia, can you tell me what a sub 1 is? It is. So Julia said, hey, a sub 1 is the first term, so a 2 is going to go in that spot. And the only thing I have left is d. So just like I said, n is 15, I better figure out what d is. And we already know how to figure out d, right? You take any term and subtract from it the previous term. So if it's something you can't easily see, always take like the third and subtract from it the second, or take the fifth and subtract from it the fourth, or take the second and subtract from it the first. And everybody knows that the value of d is 3. Okay, that's all we need. That's all we need. So now we'll come into our formula. A sub 15 equals a sub 1. We said that was a 2. Plus parentheses. We said n was 15, right? I'm just putting in where it goes. Minus the 1. Close the parentheses. And we said d was 3. So at this point, it's an order of operation problem, right? We're just trying to figure out the value of the number. So your next line, this is how your work should look. Still a sub 15. And hopefully you all agree you still got the 2. And now we got to go inside the parentheses and get a 14. And then the 3. So what would be the next step? Chloe? Okay, and can anybody multiply the 14 by a 3? What do you get when you multiply 14 times 3? Emily? 42 is correct. If you can't do that in your head, do it off to the side. Again, soon, once we get through fractions, which will be right around Christmas time or right after Christmas, which, by the way, if you don't have your calculator yet, we're starting to get there, right? It's November. As soon as we finish our chapters with fractions, we'll then start using calculators, and you'll just punch that on your calculator, 14 times 3. All right, Christina? So we were looking at how much is between each number is one way of doing it. The other way of doing it, Christina, is take any number and subtract from it the one before it. So that's another way of doing it. So seeing the amount between each number, or taking any number and subtracting from it the previous. Either way will give you the value of d. Okay, we're done now, right? And we found that a sub 15, or the 15th term, is 44. And we use the explicit formula to get us there, right? 2 and 42 is 44. Just added them up. That's how your work should look in homework if you're looking to find a term using the explicit formula. I do, listen now, everybody pay attention. I do want you to write the explicit formula first, just like it looks here. That's what tells you what to put in what place. It also helps you to begin to learn the formula by writing it for any homework problem where they ask you to find the value of a sub whatever using the explicit formula. All right. Any other questions on this before we do another example? Anybody? Okay, let's look at the second example, B there, and I probably didn't give you enough room for this one. So what I want you to do is I want you to recreate what we just did. So let me remind you, you have to find N, you have to figure out what D is. Once you have them, you should now be able to use the formula to find the 35th term. So I'm going to pause the video, give you guys time to see if you can figure should be in. So it sounds like you did a lot of right things there. If you're in the ballpark of between 125 and 150. All right, so hopefully you said that the value of N is 35. It's the term that we're looking for. And the value of D is a 4, right? It's 4 between each term. Again, 9 minus 5 is 4, 5 minus 1 is 4, 1 minus a minus 3 is 4. Okay, so our work will look like this. M sub 35. What is M of 1 and negative 3? First term is negative 3. What's our N? 35. What's our D? 4. And again, if you guys want to save a step and write your 34 there, that's okay. Now, you got to be careful, 4 times 34. So what I would do in my mind, 4 times 35 is 140. Right? But I went 1 more, and I went 1 times 4 more, so 4 more. So instead of being 140, I'm 4 less, I'm 136. But again, you don't want to really, if this were a quiz or test, you wouldn't want to trust it to that. You'd be off to the side doing your multiplication. So it looks like the answer to this thing is 133. And how many got that correct? Okay. Not too bad, right? So again, the explicit formula allows us to find the value of any given term if we know the first term and we can figure out the common difference. Christina. So 35 minus 1 is a 34. 34 times 4 is 136. Remember, whatever you get for the parentheses will be multiplied times your D. Whatever you get inside the parentheses will be multiplied times D. Okay, let's try the next one. Try C. I'm going to pause. Okay, so hopefully you determined that N was 55 and D was negative 7. Be careful with that negative 7. Remember, it's multiplication. So I put negative 3 in for P sub 1. We know this thing is going to end up being a 54. 54 times negative 7. All right, so thank you. So 54 times negative 7. This is what I did. Negative 7 times 50 is negative 350. Okay, but I need another 4 times negative 27 times negative 7 more, right? Because it's 54, not 50. So 4 times negative 7 is a negative 28. So that's negative 378. Is that right? All you guys did it on the side is probably easier than straining my brain, doing it in my head. Right, off to the side, multiply negative 7 times 54. So this gives us a grand total of negative 381. And how many got that correct? Okay. So again, they're not so hard. You just gotta figure out what N is. That's whatever term we're finding. A sub 1, in this case P sub 1 is the first term, and D is common difference. Christina. Multiplying 54 times negative 7. Positive times a negative is a negative. All right, let's turn the page here. I'm going to speed up a little. Okay, so there's our explicit formula again. So D says if you know the first term and the common difference, you can write the specific explicit formula. All right, so here again, we're going to write a formula now. But we want the specific explicit formula for this sequence. Got it? We want to make it apply to this sequence. And really, what you simply do in that is you're going to sub in A sub 1, and you're going to sub in the value of D. So this is going to go in for A sub 1, right? And this is going to go in for D. So here's where we end up. A sub n equals, I'll use my color here, I'm going to do 22n for the A sub 1, right? You just subbed in, right, the first term, plus sign, parentheses, we still have the n, we still have the negative 1, and now I sub in for the d, I put a 6. Okay, the last thing we have to do is simplify this. Now, we've only done a little bit of the distributive property so far. So my advice to you is apply the commutative property and put the 6 in front of the n minus 1. That's all I did right then on that line is swap the 6 and the n minus 1. Commutative property, right? I changed the order because you guys, you can distribute from the back, but you guys are better at the front. Clear on what I just did there? I'm just trying to make it easier for you guys to do the distributing. Okay, so next line, 22. Somebody distribute that 6 for me. Tell me what we get when you distribute. Amber, go ahead. Okay, a plus 6n. And a negative 6. I agree. Now, the last thing we do is we add like terms. Now, it's proper to put your variable in the front, so let's put the 6n in the front, right? And the only other thing we can do is add 22 minus 6, right? And then, of course, that's going to be a 16. And there's our specific explicit formula for that sequence. So it's a specific explicit formula. Sometimes you'll see it like that. They'll give it to you that way in the beginning, and they'll say, like, find the 100th term. You can do that in a second, can't you? Can you do that in your head? What would be the 100th term on this one? 100th term. Say it if you know it. 100th term. Say it if you know it. 100th term. 100th term. 100th term. 100th term. 616, right? See the explicit formula, 100th term, and it's 100. 6 times 100 is 600 plus 16, 616. The explicit formula is an easier form. When it's the specific one, then it's an easier form of finding the value of any term. What would be the 1000th term? 6016. What would be the 5th term? 46, right? And you got to do a little mental math, or just be mental, whatever the case. Christina! 600, and then plus the 16 is 616 if it were 100. All right, let's try to do that again. Second example. Write the explicit formula. If R sub 1 equals negative 3 and D equals negative 2. So here's normally, watch, everybody, before you get too far ahead, I'm fine with you guys doing this. Oops, let me just get my black. So I'm okay if it looks like this. You're going to stick the negative 3 in for the A sub 1. I'm okay if you right off the bat switch the D order and put it in the front. Because again, you distribute better when it's in the front. And that's what I would advise. Again, it can stay in the back, but and I don't mind you saving a step by doing it right then. This is how your work would look. You'd write the explicit formula first, then go ahead. So finish that off. Go ahead and finish that off. Write the specific explicit formula. And hopefully that's what you got. R sub n equals negative 2n minus 1. Questions on that? Chloe. What positive sign? Okay. Try your question again, Chloe. I didn't follow it. Yes. Correct. I mean, remember, a positive times a negative is a negative, and you're just distributing that negative too. I mean, even if you had it here, Chloe, then again, a positive times a negative is a negative. So, I mean, but don't stop. We're not done. I've got one more problem to give you guys. So keep your notes out. So I don't carry it on, but you could if you wanted to and put it there. Okay, good question. All right, I want to do one last thing. So now I want you to find R sub 50. All right, find R sub 50. Go ahead and do it. Find R sub 50. Come on, show some work like it's a problem. Give me some work. Probably going to be like one line or two lines of work, and that's it. Give me R sub 50. If you know what's going on, it's very quick. If you don't, hang in there. I'll show you in a minute. If you know what's going on, you should be about done. If you don't, I'll show you. Christina, got an answer? R sub 50? What do you think R sub 50 is? Close. I think you did too much in your head, though, unfortunately. So R sub 50 is going to be the negative 2n minus 1, right? And so it's going to be a negative 2 times 50 minus 1. We already have the explicit formula, right? And the specific one. So it's going to be a negative 100 minus a 1, and R sub 50 is negative 101. Hey, if you've got that specific explicit formula, remember, all you're doing is subbing in whatever numbered term it is. The 50th term, n is 50. 100th term, n is 100. 11th term, n is 11. 8th term, n is 8. All right, this is new to you guys, and therefore it's not very clear in your minds yet. So it takes to make sure that you take some time with the homework and try to get it settled out. I gave you some examples of how your work should look. You did half the problems yesterday, so there's not as many tonight, but we do have a quiz tomorrow. Be careful, because we have base 2 and 5 and 7 and 11 to finish up Thursday, and then we're looking at a test here in next week, so be careful.